Hello students, I hope everybody is fine and enjoying your health. So we are in continuation of the chapter metals and non-metals. So in the first tutorial, we have told you regarding the definitions of metals and non-metals. And in this tutorial, we will study about, in particular, the chemical properties of metals and non-metals. As you can see here, metals and non-metals. So let us begin. So first of all, you all people must write that what is the meaning of metal reactivity, okay? So first of all, just write down these are referred as the general equations. Just write it down. General equations in particular, okay? And on these various equations, we will check out the properties. So in case of metals, when they react with oxygen, just see the general information. So metals react with oxygen to form metal oxide or metallic oxide. So write it down. Metals when react with oxygen, they form metal oxide. Similarly, when metal reacts with water, so generally when metals react with water, they form metal hydroxide and hydrogen gas. Metal hydroxide and hydrogen gas, okay? And third, so when the metal reacts with acid, so when metals react with dilute acid, so they form salt with hydrogen gas. Salt with hydrogen gas, okay? So these three are your basic general equations that will help you out to know the chemical properties of metal. So metal with oxygen form metal oxide, metal with water give you metal hydroxide and hydrogen, metal with acid gives us salt and hydrogen. So keep this thing in the mind and let's see the further part of these examples in this tutorial. Now as I have told you earlier, so metal, write it down side by side so that you can recollect it after this tutorial is over. So metal, when they combine with oxygen, they form metal oxide. So this is the general equation I have just told you. So you can see the example here. So metal like sodium, who is very reactive, combine with oxygen to form sodium oxide. So write it down with complete balancing. So we will teach you balancing in next tutorials. For time being, write down this equation. The sodium with oxygen forms sodium oxide Na2O. Similarly with example 2, you can see magnesium when combines with oxygen form magnesium oxide MgO. So when we burn magnesium in presence of oxygen in the lab, it burns with a dazzling white light. A very bright light is produced. So in this reaction. Similarly for non-metal, again write down this equation, general equation. So when non-metal combine with oxygen, they form non-metallic oxide. Non-metallic oxide. So we have example when we burn carbon. So put the sign of delta on arrowhead. So it means we are burning it. So when we burn carbon with oxygen, we get carbon dioxide, which is a non-metallic oxide. Similarly, when we burn sulfur with oxygen, we get sulfur dioxide. So it has a very pungent smell, or we call it a strong smell, because it is a suffocating gas. So write it down, sulfur dioxide is a suffocating gas. Furthermore, if you combine or dissolve this carbon dioxide or non-metallic oxide in water, you get the acid. So carbon dioxide, when combined or dissolved in water, it forms H2CO3, the carbonic acid. Again, when we dissolve or combine sulfur dioxide in water, we get sulfurous acid. Make sure the formula is H2SO3, sulfurous acid. So these are some of the properties of metals and non-metals when they combine with oxygen. Now come with the second reaction. So what happened when they combine with water? So write it down, the two general equation. So generally when metal combine with water, they either form metal hydroxide with hydrogen gas or metal oxide with hydrogen gas. So write it down. So they form either metal hydroxide or metal oxide. Now just check out for again sodium. You know it is very reactive metal. So when sodium reacts with water, it forms sodium hydroxide and hydrogen gas. Okay? So make sure how to learn these things. So sodium when combines with water, it forms sodium hydroxide and hydrogen gas. While the metals which are low in reactivity series that will be followed in this tutorial, such as copper, silver, gold, they do not react with water at all under any conditions. Metals like write down it again, copper, silver and gold. So I have told you copper is Cu, that is its symbol, silver is Ag and gold is Au. So these are the less reactive metals, so they won't combine with water. Now comes the next, what happens when they react with acids? So we already have told you in the starting of tutorial. So when metal combine with acid, they form salt and hydrogen gas. Okay, salt with hydrogen gas. Now check out some examples for your understanding. So you can see here, so zinc is a metal combined with sulfuric acid, form zinc sulfate, that is ZnSO4, and of course hydrogen gas. So whenever a metal combined with acid, they are giving you zinc sulfate. It is also called the salt. Similarly with the second one, magnesium. So when magnesium combined with sulfuric acid, it gives you magnesium sulfate, MgSO4, with hydrogen. So again, magnesium sulfate is also referred as salt. And similarly, the last equation, write it down very, very carefully. So when aluminium combined with, say this time the acid is HCl, it forms aluminium chloride, AlCl3, with hydrogen. And in order to balance, we put the numbers. So we will let you know how to balance it by certain mechanism in the other tutorial. So 2 of aluminium with 6 of hydrochloric acid gives you 2 molecule of aluminium chloride and 3 molecule of hydrogen. So you should know that whenever a metal is combining with an acid, so this general equation should be known to you. So whenever a metal combined with an acid, it gives you salt with hydrogen gas. Now here is something that you should know it basically. So reaction with bases earlier was with acid. So it's just instruction or information that most metals do not react with bases. Okay? Only few like them react. And these reactions we will study in the higher classes. For time being, you just must know it that most metals do not react with bases. So you can just pause the video and write down the statement or take the screenshot. And similarly, non-metals, the reaction of non-metals with bases are highly complex. So as I've told you, we will do these in higher classes. So make sure for bases in your syllabi we won't have a more description. That is left for your higher classes. Now this is the table that should be learned by you by heart. Okay? Because the next topic is displacement reaction. So just draw this table in your copies. First of all, the higher metals which are reactive are on the top, and as we go down the order, reactivity decreases. Okay? So first of all, write it down in the order. First is potassium, followed by sodium, then is calcium, magnesium, you can write the symbol side by side, then aluminum, then zinc, then is iron, tin, lead, hydrogen, copper, mercury, silver, gold, and platinum. So you can see platinum is the least of all reactive in metallic series, and while potassium is the most reactive. So this has to be read, learned by heart if you want to study the topic called displacement reaction. So this whole table chart is called reactivity series. Write it down. Reactivity series we call it, in which the most reactive metal is placed on the top and the least is placed at the bottom. So reactivity series. So try to learn this series, because without this reactivity series, it is not possible for you to study the topic called displacement reaction. So I again repeat, those who are at the top are the most reactive, while those who are at the base are the least reactive. So this is only the reactivity series for metals, make sure. Now this is the example that I have just told you. So first is displacement reaction. So underline the definition. So it is a reaction in which most reactive metal displaces the less reactive metal, write down further, from its salt solution. This you have to write it for definition. So more reactive metal displaces the less reactive metal from its salt solution. So as here we can have this activity that they have taken magnesium because it is no more reactive than copper. So we place magnesium in blue copper sulfate solution. Okay. So copper sulfate solution color is blue. And when we place magnesium into this particular solution, as you can see in the diagram, so the color of the copper sulfate solution is blue, and when we place magnesium in it, So blue color of copper just disappear or fades out. So write down this data. So when the magnesium powder and copper sulfate are stirred or mixed, they change into the respective compound called magnesium sulfate and copper. So we'll see that statement again. So in this reaction, what we have done, we have taken copper sulfate in a beaker which is blue in color and placed the magnesium powder into it and give it a stirring. So what happened after it? So you can see the whole blue color of that solution more or less become colorless and copper settle at the bottom. So this is the general equation or the equation for that reaction. So magnesium combined with copper sulfate to give you magnesium sulfate and copper. So this is possible. Why? Because magnesium is more reactive. So if you write the equation again, so magnesium with copper sulfate is why possible, because magnesium is more reactive than copper. So the copper is displaced and magnesium take its position and form magnesium sulfate, as you can see in this equation. So it means that more reactive metal displaces the less reactive metal from its salt solution. Make sure salt solution should be there to get the whole answer done. And continue with it. So as I have told you, displacement reaction. So we have number of types. So just we have done a single displacement reaction in which we only talk about the single element. Say for example, in this equation you can see the reaction with iron and copper sulfate. So again, iron is more reactive to copper, so it replaces copper from sulfate and form iron sulfate, and copper is out. So question is, whenever the more reactive metal react with less reactive metal in salt solution, it displaces it. So that is the word displacement reaction. Since here only one metal is in consideration, so we call it single. And when we have double or two more or two elements or metals are there, then we call it double displacement. So again, they displace the less reactive. To get more clarification, you can have this example here. So silver nitrate, that is AgNO3, and when sodium chloride reacts with it, so they switch their respective anions, okay, the negative radicals there, that is, so silver forms silver chloride and sodium will form sodium nitrite. So here you can see there are two metals are in consideration. So again we have double displacement reaction. Earlier was single displacement. Now this is double displacement. So continue with it. The last topic you can say more or less is the topic called corrosion. So write it down. So the metals react with oxygen and moist air or moisture in the atmosphere. This phenomena is called corrosion. And when this corrosion occur with iron, we call it rusting. Okay. So make sure these equations are mentioned in your book. So check those reaction with iron, with oxygen, with water, okay, to form the rust. And similarly, we have the equation for copper that you have seen it. So copper, so you can refer your book for the whole equation. So copper with carbon dioxide and water in the atmosphere. So we can combine these components and then they react to form. You have seen that equation called copper carbonate dot its hydroxide. Okay, it is mentioned in your book. Check it out. So this is dot, and that is called the corrosion of copper. That gets its approximately green coating, you can call it. So these mechanism in which the metal reacts with the atmospheric gases as well as water content, so they get rusted, so that or they get corroded. So you can see some examples here, more or less, and make sure write down the definition for this. For in case of metal, I have told you the rust with iron, and this is the reason that you can see the color of planet Mars appears close to reddish. So because of that mechanism of rusting that might be taking place for millions of years. So that is just information for the mechanism of rusting occurring approximately everywhere. Now check out these terms which are very important for all of you. So what is valency? So it is a combining capacity of an atom. Is called valency. Make sure. So you only have to read till for this class that it is a combining capacity of an atom. And you will find that when we share some names, such as we are using the word called radicals. To underline the definition, what are radicals? So these are the charged atoms or group of atoms having a common charge which act as a single unit in chemical reaction. So basically for you, radicals are just the charged atoms or group of atoms. So they can be positively charged also or negatively charged also. So we have told you in case of positive charge, we call them cations. And in case of negative charge, as we people know it, they are called anions. So write it down. So if they are positive charge, cations, otherwise we call them anions. Then one thing, make sure when you read the table, you will find some of the element have more than one valencies. So this just write it down in your respective copies so that it will help you in chemistry in other classes. So if the valency is lower, then the name end with OUS. Okay, so if the copper has two valency 1, that is +1 and +2. So if it has a valency +1, then we call it cuprous. Okay, you can see the name here. And if the valency is more, say valency 2 here, then we call it cupric. So make sure if the name end with OUS, it means lower valency of the same element. And if the name end with IC, then it will have a higher valency. Okay. So cuprous, if I speak, you should know the valency is lower one, that is 1 only, +1. If it is cupric, it is +2. So it is for lot many elements. Sometimes you will heard about the name about ferrous or ferric. So make sure the name when end with OUS, the valency is the lower one. If it is IC, ferric, the valency is more. Now underline these terms. What are ions? So we have just told you they are the charged particles. I have told you what are cations, what are anions just now. So metal form cations because they lose electrons. Non-metals form anions because they gain electron. So it is all the process of loss or losing of electrons and gaining of electrons. So make sure. So cations and anions are the two type of ions. Now this is the most important part of your table. So please pause it and write them out. Because with these radicals you are able to write the formulae. Once you know the formulae, then you can make a compound more or less. And once you know the compound, then only chemical reaction come into the scene. So first, write it down some of the positive radicals for your standard. The sodium is Na plus 1, hydrogen is H plus 1. Just copy it as it is shown on the screen. Potassium is K plus 1, lithium is Li plus 1, ammonium NH4 plus 1, and go down the order like that. Then you can see cuprous or cupric with the various valencies 2 and 3. Then magnesium, then lead, then iron I have told you. So in case of iron 2, it is ferrous, iron 3 is ferric, aluminum is Al plus 3, calcium plus 2, barium, then gold is Au 3 plus, then manganese, nickel and palladium. So nickel is Ni2 plus and palladium is Pd plus 2. Second letter should be small, make sure. So again, we have copper 2, copper 3, if you want to understand it. So it is not there for your class syllabi. You just only know copper. It has 2 valencies. Rest we do in some higher classes. There are some modification in them. Then comes to negative radical. So it is again a big chart as you can see. Beginning with fluoride F negative 1. When I won't write any number, it means 1. So minus 1. Chloride, Cl minus 1, bromide, iodide. And you can pause the video and write down these terms and try to learn them. Then sulfate is SO4 2 minus, oxide. Then a new name called nitride, Nitride, nitride. Then sulfur. Then carbide is C4 minus. Then hydroxide you can see. Nitrates are there. NO3 minus 1. Carbonate. So that is CO3 you can write at the base. Minus 2. Then bicarbonate. HCO3 negative 1. So write it down after pausing the video if it is moving too fast for your comfort zone. Then is sulfate. Make sure sulfate is SO4 negative 2. Sulfite is SO3. Make sure the names. Then nitrate. Nitrite. NIT, it is RITE. Earlier it was nitride. तो make sure नाम में काफ़ी similarities हैं, but pronunciation is different. So in case of nitride, then nitrate, and then now is nitrite. Then we have hydrogen sulfite. When it is sulfite, it is SO3. When it is sulfate, it is SO4. And then last is chromate, CrO4 2 negative. So this is the table for negative radicals, okay? As well as positive radicals, I have just shown it in brief. So make sure when you read these tables, Write them properly and rewrite them so that this thing gets settled in your mind. Once you know these names and radicals, then you can work well with making formulae and can understand the chemical reaction and equation. So practice it as hard as possible and learn them. Okay, take care. Bye.